Hello. In this example, we're going to graph f of x equals negative x to the fourth plus 16x squared. Now, because this is not fully factored, you might try to find the possible rational zeros. But there's one thing that you need to keep in mind. That only works when we have a leading coefficient, or excuse me, when we have a constant term at the end. And we don't here. But what we do have, if you look at this carefully, is we have a common factor between these two. And what is that common factor? Well, if you look at it, x to the fourth and 16x squared, that means that x squared is a common factor. But I don't like having a negative leading coefficient out here, so I'm actually going to factor out a negative x squared. And when you factor out a negative x squared, you have to divide every term by negative x squared. So negative x to the fourth divided by negative x squared is positive x squared. And 16x squared divided by negative x squared is negative 16. Now, this right here, the negative x squared, is a monomial. It cannot be factored. However, x squared minus 16, well, first of all, notice there's no common factor, but it's a difference of two squares, which means it can factor, and it will factor pretty much the same way every time. There will be, in this case, a plus and a minus because it factors into conjugates, and just take the square roots of each one of these. Square root of x squared is x, square root of 16 is 4, and then just repeat them over here. Fantastic. So now we have negative x squared times x plus 4 times x minus 4. This is a fully factored polynomial function, which means we can just look at it and see the zeros with their multiplicities. Now, if you were in class, I would ask you for the multiplicities, and I will tell you more than likely the two numbers that you would come up with is negative 4 and positive 4. Those are the ones that most people tend to see. But that's not it. That's not all of them. There's one more, and it comes from this leading coefficient, or excuse me, the leading factor here. And you can actually set that equal to 0 if you wish, and say divide by negative 1 gives you x squared equals 0, and then that means that x equals 0. So actually 0 is a 0. And it's because you can write this, if you want to think of it, as x minus 0 squared. Notice that minus a number, well, that's the number. That's your 0. Now, let's look at the multiplicities. For the negative 4 here, came from right here, its exponent is 1. The 4, its exponent is 1. And the 0, its exponent is, well, it's 2. So it's a multiplicity of 2. So at the 1, it crosses, or excuse me, at the negative 4 it crosses. At the 4 it crosses, again, because its multiplicity is 1. And at the 0, it bounces. And it bounces because that multiplicity here is even. Fantastic. Now, we need to find the y-intercept. And actually, this is easy. Anytime the function is just written out in standard form, you just plug in 0 for the x's. So this term goes away to 0. This term goes to 0. Well, 0 plus 0 is 0. So that means your y-intercept is 0, 0. But notice that that's a 0. And that's perfectly fine. Because anytime your 0 is 0, that means that that will be your y-intercept. If it isn't, well, we've got some crazy things going on that I don't really even think are possible. Okay, so the question becomes, what's the end behavior? Well, if you look at the original problem, the degree is 4, and that's even. So they're either both going up or they're both going down. The negative out front means that they're both going down. So the end behavior looks like this. As it goes to the left, it goes down. As it goes to the right, it goes down. Fantastic. Now we just plot the points. At the negative 4, 1, 2, 3, 4. at the 4, 1, 2, 3, 4, and at the 0. And that's all the points that we have. Now we do have the end behavior going down to the left and down to the right. Now at the -4 it crosses, so it's going to cross from here going up that way. And at the 0, which is what we see next, it bounces. So it'll be coming back down here and it'll bounce back up like that. And then it'll come back down towards the 4, and at the 4 it crosses. Fantastic. Now notice again that everything kind of lines up, and then just kind of connect everything. There you go. Now notice again, I'm not trying to make this to be a perfect graph, but I am trying to get the correct zeros, the correct end behavior, and the correct behavior at the zeros, and of course the correct y-intercept. Alrighty, well, y'all have fun. I'll see you next time.